So, hello everybody again. So following on from yesterday, today we'll look at children who are at risk for mathematical difficulties or mathematical learning difficulties. We'll talk a little bit more about what is developmental dyscalculia and how is that different from mathematical learning difficulties. Later on, I'll talk a bit more about children who are at risk for mathematical learning difficulties. And hopefully by the end of this session, you'll be able to identify children who are having mathematical learning difficulties. So to start off our session, I think we have a poll for Mentimeter, so I'm going to stop sharing already. And we're going to go to Susan, who's going to share Mentimeter with us so we can see what you think about developmental. There you go. So if you go to menti.com and use the code at the top, and then you should be able to respond to this question around how familiar you are with developmental dyscalculia. And I can see people are responding. So we had 14. It's going up now quickly. That's great. I'll give it another minute or so. And don't close your Menti yet, because there will be another poll later on, and one in a minute as well. Okay, I'll give it one more minute and then we'll close down. So if you want to cast your vote, it would be now or never, so to speak. That's okay if you can't. It's just a little exercise for today. Okay, I think we can close this one. So what you can see here, and I don't know, Susan, there I don't know whether it's my screen, because I can't close the lobby. Okay, so there we go. So now I can see it. So the majority of you are somewhat familiar with developmental dyscalculia or not, and we've got a fair few are fairly familiar or very familiar with developmental dyscalculia, and that will be very helpful to me as well today. Now, if we can go to the next question. Oh, you've already done that as well. That is fantastic. So here we go and see what the difference is if you compare that already to before, and I'll give people another minute to respond. And the numbers keep going up. All right, so I'd say I'm going to close it now. And later on, there will be some more polls. So as you can see from what previously, for developmental dyscalculia, we had that the majority were on the left-hand side of the graph, so not so familiar or not familiar at all. Whereas if we go to dyslexia, we see that this curve is reversed. And that's what we mainly find in our research as well, is that people are very or more familiar with dyslexia than they are with developmental dyscalculia. And one of the things we'll be presenting today is the fact that actually they are as common within a classroom or as common within the population. So there's as many children who have developmental dyscalculia as you have children with dyslexia in your classroom. And as you may already be aware, then there's a problem with diagnosis here, because a lot of children are not being diagnosed with developmental dyscalculia or are overlooked. So hopefully by the end of this session, you'll get a better understanding of who these children might be that are struggling with mathematical development. So Susan, if it's okay, shall I start sharing again my screen? Thanks for that. And go back to here. one. My computer is a bit slower today. It doesn't want to go to presentation mode. Here we go. So what do we mean by developmental dyscalculia? So it's a specific learning disorder, and it's a neurodevelopmental disorder that is of biological origin, manifested in a learning difficulty and problems in acquiring academic skills markedly below age level. And these are manifested, these difficulties, from early school years onwards. So we already can see that children with developmental dyscalculia start having difficulties with mathematical abilities from early years onwards. And in the new DSM-5 criteria, which is the manual we use to diagnose children with special needs, it's this biological origin that is new compared to previous versions. And we'll talk a little bit more later about what are these biological origins, where might this come from in terms of brain development and genetics. The other important change in the DSM-5 criteria is that in order to get a diagnosis for developmental dyscalculia, the difficulties that children are experiencing should be there for at least 6 months. And what it means is that, we can only diagnose children with developmental dyscalculia once we've assessed them repeatedly, because we get a lot of false positives otherwise. So a lot of children might do poorly on a task one day, but don't really have developmental dyscalculia. But children who have developmental dyscalculia will persistently show these difficulties over a time span of more than 6 months and perform markedly below age level expectations. These difficulties that these children show, and we'll go in detail later on what these particularly are, cannot be attributed to any kind of intellectual disabilities or developmental disorders such as ADHD or other developmental disorders that they've already been diagnosed with, as well as not been attributed to any motor disorders or other neurological difficulties, although obviously they can co-occur with each other. I'll be co-moored a bit. So this is according to the DSM-5 criteria. Very often we are asked to specify, because developmental dyscalculia can happen, co-occur with other difficulties, is whether this developmental dyscalculia is with an impairment in reading, with an impairment in written expression, with an impairment in mathematics specifically, whether this also a number sense, fact and calculation difficulty, or mathematical reasoning difficulty. So as you can see, there, and I'll come back to this later on, there are different types of developmental dyscalculia, and some children might show a range of difficulties and other children might show fewer difficulties. I'd like us to go to another poll, if that's okay, on Mentimeter. So I'm going to stop sharing here, and Susan is going to share the next one again.
Jo, just see while I'm doing that, there's a couple of questions that people have. Stephanie, I don't know if you want to come in and ask your question, and then we'll get Jay Baker.
Oh, the DSM-5 criteria, the developmental, use it so often. So DSM-5 is the medical diagnostic manual. And so that's where this definition is from. I'll come back to some of the definitions because there are some issues around definition as well.
I've just realised my mic is up here. Sorry, that's why I was asking about the definitions as well. So I've
started with the DSM-5 criteria, which is a diagnostic manual. But obviously, children with mathematical learning difficulties is a mixed group, and we'll come back to that later on. I'm very happy to also, we may have time at the end to go more in detail about it.
Okay, thank you.
So I would like to know a little bit more about what you think of the following statements. So whether you could say something around whether the following statements are true or false. So the first one, for example, so what do we think about children with...
Can you see that, Jo? Sorry.
Yeah, I can. Yeah. So children with developmental dyscalculia grow out of it. Do we think that's true or false? You need to be very quick. Got 5 more seconds.
Sorry, I did not know there was a timer on that. I'm really
That's
sorry.
okay. That's okay. So we're gonna talk more about this. But the majority of children do not grow out of developmental dyscalculia. Let's see the next one. It doesn't matter. We'll just see what people believe. So question number 2. I can't see the question yet, but I don't know. There you go. So children with dyscalculia can't learn math. Do you think that's true or false?
Don't worry about the X's. Obviously, I am not proficient in Mentimeter, so...
No, that's all right. Let's see what happens. That is false. And we'll talk more about that as well. It is indeed false. And let's see the next one. All children with dyscalculia have the same difficulties. I already gave that one away, I think. That should be an easy one if this was an MCQ. Indeed, we'll talk more about these difficulties. Although there are some commonalities between children, and there's 2 particular that always stand out. And I will go, 2 more? So the idea that dyscalculia is all about reversing numbers. And you're a very knowledgeable audience here, because we'll talk more about that. Although number reversals are, just like with dyslexia, we do see it in children who've got dyslexia and children who've got dyscalculia, but of course it's not the fact that if you don't have reversals, that you can't have developmental dyscalculia. You can have this developmental dyscalculia and either or not show letter reversals and number reversals. So the final question. And here we go. This is, again, you're already very knowledgeable. Thank you very much for this. But indeed, we'll talk more about these things. But these are some common neuromyths, as we call them, or things people believe around developmental dyscalculia that we know are not true. So let's talk a little bit more about what we mean about developmental dyscalculia. So one of the things I mentioned is that there are 2 kind of commonalities or common difficulties that children with developmental dyscalculia show. And one is the use of immature counting procedures to solve simple arithmetic problems and the number of counting mistakes that they make that we don't see children of a similar age make anymore. Because a number of these difficulties, younger children will also, for example, omit the decade number when they're counting. So go 48, 49, forget the 50 and go 51, 52, or are unable to cross decade boundaries, for example, like here 28, 29, and then go 21, 22. We see this in younger children as well. They make these errors, but with these errors persist a lot longer in children who've got developmental dyscalculia. And then the second point around, using immature counting procedures to solve problems is the idea that as children, start to develop mathematical abilities, we talked about it yesterday, use of fingers can be very helpful because you can subitize and you don't have to count that there's 5 fingers on one hand. You can use your subitizing skills for that. But what we see is that children with developmental dyscalculia rely a lot more and a lot longer on the use of their fingers. And obviously that becomes an issue when you start dealing with more complex equations or more complex sums because you run out of fingers. And so in typically developing children, we see that they start to retrieve arithmetic facts from memory, and this is a difficulty for children with developmental dyscalculia. They seem to be able to learn things, and you think you've got it with the child, and then they've forgotten it again. It seems like they can't commit some of this knowledge to their long-term memory and retrieve it. So these are kind of two core difficulties to see in children with developmental dyscalculia. I started off with saying, it's as prevalent as dyslexia. So what that means is that actually 5 to 7% of the population has or meets the criteria for a diagnosis of developmental dyscalculia. And that's about 1 in 20 people. So if we take an average classroom of 30 children, there should be probably 1, if not 2 children who have developmental dyscalculia. And as I mentioned already before, it can occur with dyslexia or without. And as I mentioned before, it also has different names. So people might use developmental dyscalculia, but you might also be more familiar with other names such as mathematics learning disorder, MLD, or mathematics disorder or disability, MD. And different people use slightly different criteria in terms of what the cutoff point is. So for example, Geary has done a lot of research around this, David Geary, in terms of primary school age children. You can also talk around low achievers for maths, and these are children who are scoring below the 25th percentile for their age group, which is significant mathematical difficulties, but they may still improve and may grow out of it. So that's about 20% of children who score like that. But then we have the children who have MLD, mathematical learning difficulties, or developmental dyscalculia, and these two are used interchangeably most of the time, and that's approximately 7%. So the difference between these children is that the MLD children will maintain difficulties more than 6 months down the line. So they remain and those low achieve, whereas low achievers could go up or are not as profound. The other difference is that we know for children with developmental dyscalculia that there are biological differences. And these differences, they show themselves mainly in the gray density of grey matter in the brain, so in the hips, so the horizontal intraparietal sulcus, or that's about the yellow area that is highlighted here. So this is the back of the brain over here, and this is the front of the brain, and this is where the hips is placed. And these difficulties here, these areas that have been highlighted in yellow, have been linked to performance on symbolic magnitude difficulties. So this is where yesterday we were saying which set has got more dots in it, the red or the blue one. Sorry, that's non-symbolic. But also if you have to say which number is larger, and you see, for example, a 4 and a 7, and you have to say that 7 is larger. So knowing where is more, this ability that links to your number sense, a core area, a core ability for mathematical development, is related to this kind of hips area in the brain. We also know that developmental dyscalculia, but not necessarily mathematical learning difficulties, run in families. So this is one study, for example, here that I've highlighted is by Shekhef in 2001 that found that if you look at children who meet the criteria dyscalculia, you also find that they have mothers, fathers, siblings, and second-degree relatives who meet the diagnostic criteria for it. More recently, there are studies that can look at the spectrum of genes that might be involved in it, and this is by Kovas et al. 2014. What they did was they scanned the genes of lots of people to find out which are the polygenes that are involved in developmental dyscalculia, and indeed they found that it's sorry, this is blocking my screen, so I'm going to is that there are many genes probably, so it's across many genes. There are small effects between those who meet the criteria for developmental dyscalculia and typically developing children, showing that there might be a lot of genes involved in the mathematical learning difficulties. So what is causing then developmental dyscalculia? There are actually a number of hypotheses. We're not quite sure yet what the difficulties are. There is one that is the core deficit hypothesis, which argues that children with developmental dyscalculia have a single core deficit in this magnitude processing, knowing where is more, whether that's symbolic or non-symbolic. And this is what we yesterday discussed relates to the number sense, having a sense for numbers. Where do they go and how do they relate to each other? We also know, as I already showed you a minute ago, that this relates to the intraparietal sulcus in the brain, which is different for those who've got developmental dyscalculia compared to those who do not. And we have evidence from numerical approximation tasks. So there's loads of studies that have examined the symbolic and non-symbolic magnitude comparison in children who are at risk for mathematical learning difficulties, in children who have mathematical learning difficulties, and those who've got developmental dyscalculia, and they all show impaired performance on these type of tasks. Now, although this is a possibility that children who've got developmental dyscalculia have difficulties with number sense, and therefore they can't really know how numbers relate to each other, and that might mean that they keep making mistakes in their counting, for example, especially crossing boundaries, etc. However, this deficit hypothesis does not explain why children wouldn't be able to commit things they've learned to their long-term memory, or why they wouldn't be able to retrieve number facts from their long-term memory, for example. So a second hypothesis was proposed, and is the access deficit hypothesis. And what this hypothesis argues for is that in order for children to be very good at mathematical abilities, they have this number sense, which is, as yesterday we discussed, develops very early onwards in life. And, infants have some kind of understanding already around what is more, what is less, but this core ability to start subitizing. But obviously, once then children start learning the symbolic knowledge, they have to link the two types of knowledge to each other, and know kind of that, okay, so what is 4, what does it really mean, and where is 7, and how do they relate to each other? And so this access deficit hypothesis argues that there's a deficit in connecting this learned symbolic knowledge to these underlying magnitude representations that these children have or might not have because it's impaired. So these are the two hypotheses that are at the moment being tested within developmental psychology. But one of the things that's already transpiring, which might complicate this argument and why it might be that, we have a little bit of conflicting evidence, is the fact that developmental dyscalculia is heterogeneous and also often co-occurs with other developmental disorders. So let's just have a quick look at those. So for example, we know that children with developmental dyscalculia don't just show deficits in the domain-specific difficulties related to mathematical development, so the number sense, but they also show difficulties which are domain-general difficulties, such as, we see that they might have working memory difficulties, executive functioning difficulties, as well as processing speed and spatial processing. And we also know from our own research, this is one study, there's another study that was done by Bartlett et al., that there are different causes for mathematical difficulties. So we looked at 71 children who were aged between 3 and 5 years old, and they were all at what we call at risk. So they didn't meet the criteria for developmental dyscalculia because we only assessed them once, so we wanted to be careful and just said they are at risk. They were performing below the 20th centile for children of their age range. Below the 35th centile, and they didn't have any difficulties with general reasoning abilities. And what we did was we looked at, okay, so how do these children perform, for example, on approximate number sense tasks, so where they had to say where is more, blue or red dots, a visuospatial task, which was a pattern construction task where they have to copy patterns using 3D squares, cardinality, so it was a counting task, and they had to give us a particular number of items, as well as a speed of processing task. And so this is a cluster analysis. What it means is that we put these 71 children in an analysis that kind of defined then how these children could be grouped together based on the performance on these 4 tasks. And what you see here is that we have a group of children, for example, and their profile looks like this. So they're weaker on ANS and they're okay on visuospatial. They're typical. They're weaker on cardinality, but they're very weak on speed of processing, for example. But we had another group of children who also are poor at maths, and look at their visuospatial abilities. They're very low compared to the other children. Whereas we had 2 groups of children where actually one group was excelling on all of these tasks, yet had mathematical learning difficulties, and one group that was not better or not worse than the typically developing children, but they still had mathematical learning difficulties. And what that means is that these 2 groups of children are showing mathematical learning difficulties caused by things we didn't measure in our study. So we know that there's 4 and probably even more groups, obviously we can't assess children on everything, of children who have mathematical learning difficulties. Also, you can have comorbidities. So we know that 40% of children with developmental dyscalculia also have a diagnosis for dyslexia. And one of the reasons why this might co-occur so frequently is that there might be a common deficit in terms of processing speed and working memory and executive functioning, as I mentioned before, and might relate also to phonological processing, because you also need that for obviously mathematical development, because we touched briefly on it yesterday, because there's a lot of overlap obviously between mathematical development and language development. You know, in order to be good at maths, you also need to know the words like before and after and larger and smaller and all the language that comes with mathematics as well. And we see also a great overlap between developmental dyscalculia and ADHD. So about 24% of the children with developmental dyscalculia meet the criteria, also have a diagnosis for ADHD. And this could be linked to the fact that both have difficulties with attention and working memory difficulties. So we discussed this yesterday, you know, for mathematical abilities, you often have to maintain information in mind and manipulate that in some kind of way to find the answer or to solve an equation. There are a number of children who don't have developmental dyslexia per se, but who might be more at risk for developing mathematical difficulties. And this was a study by Morsia Sanai et al. In 2018 at Queen's Belfast in Ireland. And what they found is that the children in Ireland who were most at risk for mathematical difficulties were those who lived in deprived areas, who were eligible for free school meals, who did not speak English as their first language, who had lower IQs, who had lower attendance rate, and who had special educational needs. And this is how you can see how being at risk for mathematical learning difficulties and developmental dyscalculia are actually 2 separate things. Because although these children have learning difficulties, they're not necessarily caused by a biological origin or by a genetic outcome, but more about the socioeconomic circumstances or the language at home that is being used. So it's quite important to keep these 2 things in mind when you see a child that has mathematical learning difficulties, is whether these children fall into this group because they come from deprived areas, or whether they really have developmental dyscalculia. Another aspect that co-occurs a lot within developmental dyscalculia, which is anxiety, which is an emotional factor rather than a cognitive factor, of course. We know, we touched upon it yesterday, is that 60% of students might say things like, I often worry that it will be difficult for me in mathematics classes. I worry that I'll get poor grades in mathematics. And so one of the things that is not quite clear is that, yes, children with developmental dyscalculia are more likely to have anxiety for mathematics, but what the cause and effect here is. So is it that children who have anxiety related to mathematical abilities, that this anxiety impacts on their working memory, because there's a school of thought that thinks that if you're highly anxious, it takes space away from your working memory in terms of that your brain gets preoccupied. Another school of thought thinks that if you're very anxious, your brain goes into a different defense mode and therefore you can't think so much. But both of these explanations would mean that you'd have poorer outcomes. Or is it that children who have poor outcomes already know that they don't do well and therefore will have higher anxiety when they do maths? So it's kind of, at the moment, not quite clear of what's the chicken and the egg here, but the two co-occur a lot. And when we were doing our study, which was looking at who are children at risks in preschool environments across 16 preschool schools in London. We even had 4-year-old children who had mathematical learning difficulties who would crawl under the table when they saw our research assistant come in to kind of go like, I don't want to go and play with her because I'm not good at maths. So it starts, that maths anxiety can start very early onwards. The other thing of anxiety is also to look at the parents and the teachers, and I've touched upon this yesterday, but there's an interesting study that was done by Maloney et al. In 2015. So when, for example, parents who either had low or high anxiety did very little homework with their children, the students' maths growth was not impacted. When these parents showed high maths anxiety and did a lot of homework with their children, those students' maths scores were actually declining. And because we know that mathematical difficulties run in families, you can see a cascading effect here happening between parents maybe struggling with mathematical abilities, having higher anxiety, and this may already affect their children's abilities, even when it's not clear whether these children have also mathematical learning difficulties or not. There are a number of screening tools that you can use to see whether children have math learning disabilities. So the numeracy screener, which was developed by Daniel Ansari's lab in Canada, is an online test that can be used to judge children's mathematical ability, and it's related to this, which one is larger. It's a symbolic and non-symbolic one. I still said here it's a pencil and paper tool, but I think they also have an online version now. And it's very easy to administer, and then you submit the scores and it will give you your scores back very quickly to see if a child is at risk. Of course, it's not a diagnostic tool, it's a screening tool. So it's a screening tool that will tell you whether or not a child is at risk, but it won't give you a diagnosis, because you can only give a child a diagnosis once it's assessed for a number of times across 6 months. The other one, which is designed for teachers and psychologists, which was designed by Nancy Jordan at the University of Delaware, which is the Number Sense Screener. And again, it's linked to an intervention program for children who are at high risk. But there is a cost associated with this one, whereas the other one is free to be used. So just to recap a little bit before we finish for today. So in terms of developmental dyscalculia, we see difficulties in the following areas. So these children might not know how numbers fit together or be able to make a number line, for example, have difficulties with counting, have difficulties with calculating, but especially with recalling maths facts. Things like, number bonds, extremely difficult for these children to learn, because actually you can just learn them even without understanding. Most children could, just learn them and retrieve them from memory, and children with developmental dyscalculia can't do that. Understanding concepts like less than, more than, even understanding that addition means you go up the number line, taking away means you go down the number line, or it needs to be a smaller number. Telling left from right is another one, which again relates also to dyslexia, similar where we see there. Reading a clock could be a problem, as well as working with pounds and coins and understanding the value of money. So I hope that I've shown throughout that the children with developmental dyscalculia don't grow out of it. It's something they're born with. It's in their genes and their makeup, is that they struggle. It's also, we see it in the brain development. Of course, children can improve in terms of, interventions, which we'll talk about next week, do have an impact on developmental dyscalculia. And children can find alternative strategies to help them to overcome their difficulties. But it's not something that will get better as they grow older, that they will automatically catch up. The difference will always be there. Children with dyscalculia can learn mathematical facts, but the difficulty is committing it to their long-term memory and being able to retrieve facts directly. We've talked about how different children with dyscalculia actually have different difficulties, and there might be different subtypes or different groups. So it's not just about reversing numbers, although that might be that some children do show issues with reversing numbers. And, you know, most people with developmental dyscalculia have average to above average IQ scores. It's just the fact that they have problems with mathematical abilities. So that's all I wanted to say for today. Thank you very much for listening. I'll stop sharing my slides now so that I can answer any questions you may have.
Thanks, Jo. Again, really, really interesting information. I'm really looking forward to next week to get some of the strategies and some ways of embedding some of the apps and resources that you've found to support children and families. We do have a question. Now I'm just going to bring that person in, if that's okay. So Steve.
Yeah,
welcome
hi.
back, Steve.
Yeah, hi again. Just a question actually. In the penultimate slide there, you said that people with dyscalculia could have difficulty reading clocks. Now, is that specifically digital clocks or analog clocks or both?
It's both, and it's again because in order to read a clock, you also need to have an understanding of time, and time is something that relates almost to a number line, so knowing how long is a minute and how many minutes go into an hour, that kind of understanding. So it's not just what I mean, you're absolutely right of picking me up on that. It's not just the fact I can't read a clock, but also understanding then what that means. So if you say, well, it's 6 o'clock, what is that? And how is that different from 7 o'clock, for example?
Right. Yeah. Smashing, thank you.
Thanks,
I
Steve.
was just wondering whether you know, if you had someone who had this issue, whether you'd be better off getting them a digital clock because they could maybe read it better. Well, of course, what you're saying there about the understanding of time, that makes sense to me. Thank you.
Yeah, so often it's recommended that, yes, digital clocks are better than analog clocks, but obviously it still might not explain how they know what a 1:45 means or a 1/4 and what that really means in terms of time management, for example.
Okay, we do have a question in the chat panel from Miss Cash, and she is asking, her microphone's not working, so she has a pupil in primary 3 who is dyslexic. He has very poor numeracy awareness, and I guess she's now wondering if he may have DD, developmental dyscalculia. What would you advise that I do as a next step?
Okay, that's a very good question. Okay, so there are a number of things. Is first to kind of rule out that or get a good understanding of what are the difficulties in terms of number awareness. Is it counting errors, which are very frequent for children with developmental dyscalculia? Is it not being able to retrieve facts from memory? But also, you know, is it related to any other difficulties, such as, you know, attention, working memory? Do they speak another language at home? So is it a language or is it a socioeconomic status factor? You could use the number screener that I put up, you know, which is it's a hyperlink, and I can again post it later on. Let me see if I can do it now in the chat. But also is to speak to your Senko and an educational psychologist, because actually children, you know, should show difficulties on a standardized mathematical assessment for more than 6 months. And the cutoff scores that are used for children with developmental dyscalculia do differ sometimes. Some people use, you know, lower than 25 25th centile, other people's use below the 15 centiles, or 2.5 standard deviations away from the mean. But yeah, speak to an educational psychologist to do a proper assessment, and an assessment twice, really, 6 months apart.
Perfect. There was a question earlier, and I'm just trying to find it. Stephanie Bennett, you were asking about the criteria. I don't know if you want to come in.
Yeah, you mentioned criteria when you were talking about the different studies and things. Was that the DSM criteria that was being used to identify developmental dyscalculia?
Yes, yeah. That's kind of the handbook for special needs that most cognitive psychologists would use. It's an international agreed one. You also have, that's the American one that's mostly used in the UK by clinical psychologists here. You can also use the European ICD-10, also ICD-11, I think is out now, criteria. And they kind of, that's what I mean, they kind of slightly differ around, how much of a nonverbal ability should be typical, for example, or how big the discrepancy between nonverbal abilities and, because the same is true for developmental language disorder, and how big that discrepancy needs to be between nonverbal ability and language difficulties, mathematical difficulties, etc. needs to be. So yeah, it just differs.
Okay, thank you.
Thanks, Stephanie. So, Mrs. Simpson, do you want to come in and ask your question?
Hi there. I was just wondering at what age you would think about... Can you hear me?
Yes, yeah, thank you.
Sorry. I was just wondering what age you would be thinking about going for a diagnosis. Would it be well through the primaries before you would do that? You wouldn't certainly be thinking about it in preschool, or...
We've diagnosed children in preschool. You can see the difference already from age 4 to 5 very clearly. It's difficult to see it in children younger than 4 because our standardized assessments for mathematical ability, so a common one that is used is the TEMA, the test for early mathematical abilities, and that is a standardized mathematical abilities test that can be used with children from the age of 3 onwards. I think their upper range is 8. And then you can use other standardized tests that is not now. But the TEMA, at a lower end, so for children who are 3 to 3.5, it's not precise enough. And again, you need to test the children twice, right, 6 months apart. So you could start at the age of 3.5 and get a diagnosis by around the age of 4. So we can go as young as that. And there's lots of interventions for children who are at risk for mathematical learning difficulties for preschool ages already.
Okay, thank you.
So if anyone else has any questions, please just put your hand up or pop it into the chat panel and we can bring you in. I suppose I've got a wee question. I don't know if there's an answer to this, but there was a 2009 survey of adult learning in Scotland done. And the results of that indicated that there was 1 in 5 of the population that had an issue with literacy and numeracy. And I wonder if there has been any correlation between that and developmental dyscalculia at all.
So a proportion of those will have developmental dyscalculia, and then a proportion of them will be performing lower because they might have dropped off from what we call the maths pipeline. So, you would assume that at the start, because we mustn't forget that developmental dyscalculia is a developmental disorder. It's a genetic learning difficulty that is math specific. But obviously, at the beginning, we think that all children are the same. Of course they're not, but they should have the same potential. So they should, if they all want to become mathematicians, they should be, with education, they should be able to keep on growing. But what we see is that, that a lot of people stop in terms of, and drop maths as a subject, especially around GCSEs and even before that in an A-levels, and that if you look at the number of students who take an undergraduate degree that is heavily based on maths, for example, or even then before, going further PhDs, that group becomes very, very, very niche. And we're looking at the data right now. And so the question is, why is that? And those are, if we understand more of that pipeline, we'll be able to intervene more quickly through, educational interventions. Whereas with this one, it's more like, you can improve them, but they will always have difficulties.
Mm-hmm. It just popped into my head, because and I wondered if anyone had actually looked at the data, looked at both sets of data to see, and how they correlated, I guess, and so then you would have your interventions, a bit more focused. It's probably,
Well, I think this is where the difficulty lies. So the study I showed around the Irish study, that's what they did, is they assessed thousands of children at primary school age and just assessed of who are, top performance on mathematical abilities and who are, in the bottom, and are these children from different socioeconomic status or language, ethnicity, but who are also the ones who are really having developmental dyscalculia. And so they also found it's 5%. And then you've got, up until 20%, which is 1 in 5, of people who are low performers, but for different reasons. So there is a wide scope. And I think, in terms of interventions, it's an interesting one, because although we find that there are different groups of children in terms of what's causing their mathematical learning difficulties, we do find that a number of interventions work for all children. And that's kind of the interesting one there, is that with a couple of good practices, you could probably raise a lot of children even when they have developmental dyscalculia.
Mm-hmm. We did have a question from Mrs. Clokey.
It was yes,
I don't know if you want to come in.
Oh, hi. I'm sorry, I've got noisy children in the background. Can you hear me?
Yes, that's fine.
I think it was kind of on the same thread as what you were just discussing. I'm currently supporting a pupil in primary 7, and it was just really to ask about going forward into high school. We have all these, you have so much support if you identify somebody. Oh, sorry. If you identify somebody as dyslexic and going on to university and things, but what sort of supports or acknowledgement is made if somebody's identified with these difficulties in maths?
So at a higher level, it's things like allowing them to use manipulatives for a lot longer. And one manipulative is a calculator. So people with developmental dyscalculia have difficulties retrieving facts from memory, even simple, 4 times 4, timetables. So a calculator could really help, a piece of paper so they can break it down, more time to work it out. And again, similar to what we see in dyslexia is this, if you've got crowded worksheets, that's really not helpful for children, because if you're already trying to work out, is addition going up, is it going down, or what is this maths problem trying to, what's included in this maths problem, and you then have multiple maths problems on one page, the numbers even become more confusing. So kind of clear separation, clear spaces. If you've got pictures on a page, making sure that picture is meaningful and not distracting, because pictures have a lot of numbers in them as well. If you look around you where you are right now, and I would say to you, well, how many things can you see that relate to numbers or maths? You'd probably come up with at least 5 to 6 things. There's a clock in your house, or there's numbers on a page, etc. And those are all things that if you've got developmental dyscalculia, that could become confusing. So those are just a few, manipulatives, clear spaces. If you use a picture on a page, make sure that it's a meaningful picture that helps the child or the young person to actually solve that maths problem, rather than just being a picture, and more space, more divided. I hope that helped.
Yes, it does. It was kind of, and I don't know if anybody else would know this, but in Scotland, when they come to doing exams, if you had dyslexia, I think you would be given additional time. But if you were identified, would that also be the case with number?
yeah, it would be also there's actually a lot of overlap in the recommendations around how you'd support a learner with dyslexia and a learner with dyscalculia in terms of like overall strategies, extra time, etc.
Brilliant, thank you.
Can I just jump in? Sorry, I'm actually an educational psychologist, and we've looked at this, and I've written it in the chat. But I talked to I was in correspondence with people with the SQA, and as long as you can evidence that someone would be put at a substantive disadvantage if they didn't have it, like a non-scientific calculator or a 100 square or something like that, then they can have it in. They can have it as an assessment arrangement. They can have extra time as long as it reflects what they've already had in their class. You don't need any sort of identification or label to get that because they're very much needs-led, the SQA. So I don't know if that helps.
It's very helpful, Stephanie, because obviously I'm not an educational psychologist in Scotland and the systems are all different, aren't they? So I know a bit more about the English system, but thanks for that. That's very helpful.
Yep, thanks very much, Stephanie. That was great. Eva, do you want to come in? We can maybe take a couple more questions before we round off for today.
Yes, I wanted to ask, I did some training on maths recovery, and it was based very much on the New Zealand basis, and then does maths recovery, because it's a short kind of very intensive work and it's all about numbers and number sense and counting backwards and forwards, does that help children with dyscalculia?
There is evidence that it helps children. I think and there's a number of interventions that have been shown to help children with mathematical learning difficulties and dyscalculia. I think what we haven't done enough in research is to get an understanding of who are the children who benefit, because there's always children who don't benefit from these programs. And so that's where we need to get a better understanding of who these children are. Yeah, so that's the short answer, is that yes. It should.
Thank you.
Okay, we could probably take one more question if anyone has anything. That we have Joe here with us today, so if there's anything, so we will send out the presentations if that's okay with you, Joe.
Yeah.
So we'll send out the presentations for the 3 sessions just after the 3rd session, which is next week. Final call for any more questions? Oh, we have one. So Stephanie?
Sorry, it's me again. This is a bit of a research interest in my service. My colleagues are in the chat, it's somewhere listening as well. I was just wondering, the Education Scotland haven't had any information about dyscalculia on their website or anything for years, and the emphasis was much more on the making maths count and the just developing maths. So is this the start of looking at dyscalculia more specifically with Education Scotland? Like, I know we have the Addressing Dyslexia toolkit in Scotland, which supports assessment and interventions for literacy difficulties, but is this the start of looking at numeracy difficulties in more detail? Because at the minute we don't really have that whole discussion about definitions and things. It's unclear which one we should use, because it's not like we have a definition in Scotland, or even the Psychological Society, British Psychological Society doesn't have a definition either. I know the BDA have been looking at things, and I know that Department of Education had one in 2001, but then they stopped using it. So it makes it really difficult to, like you're saying, to talk to the education psychologist, and I would be very happy to talk to any of my schools about this, but what definitions are we supposed to be using? What criteria are we supposed to be using? I suppose that's a general question for everyone. I'm not sure there's a clear answer.
So for Education Scotland, Stephanie, there we go, we've got someone from the maths team. Thank you, Maria. Come on in.
Hi, Susan. I won't put my camera on because I'm full of flu and I just look... I know, so sorry, I just thought I would quickly come in to maybe answer that last inquiry, if that's okay. So there's a working party, and I was going to type this into the chat, but there's a working party, short life working party that I'm part of at the moment, and that's with members from Education Scotland Inclusion team, Numeracy and Maths team, and some members from Scottish Government. And the main aim of that short life working party is to get that Scottish definition of dyscalculia. And we meet quite regularly at the moment because we've got a bit of a deadline that we set ourselves by the start of next, and I know that seems quite it's not as specific as we would like it to be, but we're saying early next year. So we've met quite a few times already and we've been teasing that out. So it's a kind of watch this space for the definition, but we've made huge leaps and bounds forward already in the meetings that we've had, just about getting that quite tight and I suppose what we're looking for is to make that quite inclusive, easily understood, and playing about with the wording and the language to make sure that it's actually, fits all our audiences that we want that to hit. So that should be, as I say, early next year. So hopefully that will help. And on the back of that, myself and one of the other members of the Numeracy and Maths team at Education Scotland are building a page at the moment on a professional learning community, and that will have some mini guides. It will have some checklists, just those things that might just be really practical support that will be hopefully really helpful for people when they're just looking for something that they've maybe not tried before. And that's all being built in the background at the moment. And again, we're hoping that will start to be made public very, very soon. So there's quite a few things in the pipeline just now. If you just watch this space, and I'll maybe send you my email address if you either want to have another chat about it, or I can give you some details when we've got that definition ready, if that would help. So sorry, I'll pass back to you,
that
Susan.
would be really good.
No
We
problem.
are currently looking at our guidance at the minute, but we've been holding off because of, we held off for today to see what was going to be said. But yeah, any information we can have that we can pass on to our sort of local authority and put in our psychological service practice paper. So that'd be very helpful. Thank you.
Thank you, Maria. That was, and I'm sorry to hear you've got the flu. I hope you feel better soon. But thanks very much for coming in there. That was really helpful. So we've only got a minute left, Jo. So I'm just going to thank you again very much for your time and your expertise and sharing that with us. I'm really looking forward to next week, where we're going to learn some strategies to use at home and in the classroom. But I just want to give you an opportunity, if you had any last things to say before we round off the session.
Thank you all very much for your questions and comments. And I think this one around, I didn't focus so much on definitions and different criteria that are being used. But if you want to know more, I can definitely give you some more information around what's used within the field more broadly and whether that could help. So yeah, very cool.
Okay, well, thanks again, Jo, and for everybody else, thanks for spending your time with us this afternoon, and we'll see you next week. So have a great rest of your night.
Thank you all very much. Good night.
Good night.